Hey everyone, it's Justin again. In this lesson, we're going to learn how to handle equations when they have variable terms on both sides of the equal sign. We'll also complete two examples together. Remember, the ultimate goal when you're solving an equation is to get the variable by itself, or isolated. So if there are two terms with the variable in them, that's a problem. We can't get both of these n's alone. Take a second and make a prediction. What do you think we can do to solve an equation like this with two variable terms? Well, if having two variable terms is the problem, then we just need to get rid of one of the n terms. We've become pros at canceling out terms. Now we just have to do it with a variable instead of a constant. We can pick either of these n terms to cancel and it would work, but let's try to get rid of 3n. What do you think I can do to both sides of this equation to cancel out this minus 3n on the left side? Since this is a minus 3n, the inverse would be a plus 3n. So I want to add 3n to both sides of my equation. Now when I combine my like terms on the left, what happens to minus 3n and plus 3n? Yeah, they cancel out and just leave the 16 by itself. And on the right side, positive 5n plus 3n makes 8n. We haven't touched the minus 8, so that just comes down unchanged. So we were able to make this look like a regular, normal two-step equation. From here, we can solve this just like we normally would to get that n equals 3. Now let's back up. We solved this by first canceling the minus 3n on the left side, but we could have canceled either variable term. What if I wanted to cancel the 5n on the right side instead? Now here's the thing. We can see that the operation to the right of 5n is subtraction, but notice that what's being subtracted here is 8. When we focus on just the 5n and the fact that it's a positive term, we can see that the inverse would be negative 5n. So what operation do you think would represent a negative 5n? Subtraction. So we actually want to subtract 5n from both sides. Now 5n minus 5n cancels to make 0, leaving the minus 8 to come along as negative 8. And on the left, negative 3n, thinking about the sign from the subtraction, minus another 5n makes a total of minus 8n. And the 16 will come down unchanged. You could now solve from here again and get the same answer as we did before of 3 for n. So, when you have an equation that has variables on both sides of the equal sign, you want to cancel one of the variable terms by doing the opposite. To find the opposite, you may want to look for an operation if it's at the end of an expression, like 3n is on the left, or you might look for the sign of the term, like positive 5n if it's at the beginning of an expression. Notice here that we're starting to blur the lines between operations and signs. The truth is, it's that operations and signs are interchangeable. Subtraction and negative signs serve the same job in expressions and equations, and addition and positive signs are also the same as each other. Getting used to thinking about operations and signs interchangeably is going to be really helpful for you moving forward. Then, once you have only a single variable term left, you can solve the equation like normal. Let's do a couple of example problems to practice. Our first example problem says to solve for a, and we have the equation negative 3a plus 6 equals 31 plus 2a. Since there are variable terms on both sides of this equation, we need to start by canceling one of them out. You could choose either the negative 3a or the plus 2a to cancel, but just so that we can work together, let's try to get rid of the negative 3a here. If this is a negative 3a, what can I do to both sides of the equation to cancel it out? Remember, signs and operations are interchangeable, so the opposite of a negative 3 will be adding 3a to both sides. What will my equation look like when I simplify this? Negative 3a plus 3a makes 0, so on the left, we just have 6. On the right, I will combine my like terms, so 2a plus 3a makes 5a, and then the 31 just comes down because we haven't touched it. Now this looks like the kind of two-step equation that we're comfortable with. Pause the video here to finish this one on your own. Now, I'm no longer going to show you our two-question solving structure on screen, but you can continue to use it on your own for as long as you want. As you get more comfortable and confident with solving, you may find that you will rely on our structure less and less. Back to the equation. First, I need to cancel the positive 31, so I'm going to need to subtract 31 on both sides. 31 minus 31 makes 0, so I'm just left with 5a here. On the other side, 6 minus 31 makes negative 25. To undo multiplying by 5, I'm going to divide by 5 on both sides. 5a divided by 5 makes 1a, or just a, and negative 25 divided by 5 makes negative 5. So our solution is that a must be equal to negative 5. This second example problem says to solve for v, and the equation is 1 minus 4v equals 12 plus 7v. Again, we could choose to either cancel out the plus 7v on the left or the minus 4v on the right. Either way would work just fine. Just so that we can work together though, let's work on canceling out the plus 7v on the right-hand side. Pause the video here and try to cancel this term on your own. Plus 7v can be canceled with minus 7v. On the left, negative 4v minus another 7v makes a total of negative 11v. When we bring the 1 down, that makes 1 minus 11v. On the right side, 7v minus 7v cancels out and just leaves 12. Now we've got a regular two-step equation, so go ahead and pause again here to finish this off. Here I have a v that is being multiplied by a negative 11 because of the subtraction, and we have a 1. Since we solve in reverse, I'll save the multiplication for last. A positive 1 is canceled by a minus 1, so to get rid of the positive 1, I'm going to subtract 1 from both sides. On the left, 1 minus 1 cancels, and that minus sign is going to stick around as a negative 11v. On the right, 12 minus 1 makes 11. Now all that's left is to undo that coefficient by dividing both sides by negative 11. On the left, negative 11 over negative 11 makes 1, but I don't need to write the 1, so this is just v. And on the right, 11 over negative 11 makes negative 1. So our solution here is that v is negative 1. When it comes to solving equations, you can only isolate the variable when you have a single variable term. If there are variables on both sides of your equation, you'll need to cancel one of the terms by doing the opposite to both sides. To determine what the opposite is, you want to look for either what operation comes directly before the term, or if there is none, look at what sign the term has. Keep in mind that a negative and a subtraction function the same way, and so do a positive and addition. You can use this handy trick to help cancel constant terms too. When you use these strategies to help you solve equations, you'll get to the solution in no time. We're just about at the end of our lesson video, so make sure that you filled out all of your guided notes, and then you'll move on to the practice game. See you next time!